if you look at today's, say, one phallic shaped vibrator has somewhere between 20 to 50 parts in it. Sounds complex. It's not that complex. It's mostly just like a rotary motor on a cam that it's kind of like when your washing machine is on the spin cycle and it's off and it goes dun 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 dun. That's basically the motor that's in there. OSE 2 has almost 250 parts in it. It's extremely complex. We use actuators, we use robotic actuators, we use all sorts of firmware that allows the product to locate where the product is and where, like on OSE 2, there's actually a part of it that strokes, that's supposed to stroke the G-spot. So there's a ball that moves along moves along a cam back and forth, and the product has to know where that ball is at any given point, so it can send it home when it's done, or it can recorrect itself if something goes wrong. So you don't see that in traditional sex tech products. You just don't, which is why it makes it a lot harder to source some of these materials. It also makes it a lot harder to find a good manufacturer. Luckily, we did find one. We went through probably a dozen before we actually found somebody that knew enough about what they were doing. And we tried desperately to find a manufacturer in the US. We started in Oregon. We're in Oregon, right? We started in Oregon, nothing. Then we started looking US and just like anywhere stateside. Absolutely no one had the ability to create the kind of firmware, the hard plastics, the silicones, the electronics needed to create a product like this, let alone the engineering capability. So we did go to China, and we work really well with our manufacturer, but it took us a while to find them because nobody had the engineering capability or experience to create something this complex. So it's been a bit of a wild ride, but we're very happy with the manufacturer that we have. They're absolutely brilliant, and they're actually able to work pretty well with our engineers in a way that our engineers actually iterate here in-house. So we have a multi-compliance 3D printer where we can actually literally print something up. This is a spoon. I don't know why I grabbed a spoon. We print something up that's super complex, and then we wire it, and then we get it moving. Oh, here's a bachi. So we can actually print this whole thing up, and then we can print up a negative to do a cast for the silicone also. So we can actually create the whole product here in the lab, and then create the actuators and hook up that product to a power source and a computer as the firmware, and test it out here in the lab. And we can do that whole process, make small tweaks, and reiterate those small tweaks within a 24 to 72 hour period of time. So make those small tweaks until it's just about as perfect as it can get. And then we take that just about perfect product and we send it to manufacturing, and then we continue to work with them there.